Okay, good morning, class. Is everyone back? Anyone not back today? Okay, good morning, class. Sit down. Okay, come. Yeah? Sorry? Jason? Oh, Alison, what happened, Alison? What's my personal stuff? Oh, it looks like you all are looking at each other trying to collaborate a lie. Huh? Corporate, huh? Got corporate insurance, huh? Oh. You say I'm genuinely sick. With a genuine look. Okay. I genuinely believe her. Okay, so let's start. Okay. Okay. Can you take out your topic 6? Okay, so the last time round. Okay, so last year I'm so sorry. So we will do practice set 1 tomorrow. Is it okay? And you're all done. It was supposed to be done last week. Then on Wednesday we will do topic 5 practice set 2. Is it okay? On top Friday we will do practice set 3. I wanted to mark, but I saw Saturday only like 9 people submit out. So you submitted. Oh, well done. Who never submit, please your hand. Huh? So is there a reason? Do you expect me to give the same allowance for all the things? Okay, I understand. But at least, I understand. But it will be nice if at least you did. Huh? Huh? What's it? I know about you. Yes, do we? Okay, that's okay. Isaac, give me. What's that? Mine already, huh? Okay, so I start. Increasing and decreasing function. Okay, the last time round we were at question 1.2, right? 1.2. Okay. Okay, huh? Okay. So shall I go through 1.2? Or are you okay? Maybe I go through 1.2. Or you're still doing? Okay, maybe I give you some time to attempt 1.2. Let's continue from here. Okay, today is lesson 45. Today is lesson 45. This is the 20th of April. Time has passed very fast. Okay, huh? Can I? Yes? Yes, Mitra? So, anything? Anyone never get back all your homework sets? All got get back, huh? I mean, there are still some homework that I haven't marked finished. Like your modulus assignment. Just give me some time hour. Okay? At the same time, Google Sheet, if you are observing, just go to the Google Sheet and you just check the lesson log. So in your lesson log, I will put the documents, I'll put the YouTube channel link as well. Okay, if I got record, but just know that there's some delay. Okay, the fastest, if you want to watch for those who missed that lesson, just go to the YouTube channel straight away. Okay, can Pass one. Okay. So remember the last time we said that increasing function is the fact that your gradient is positive, it's going upwards. Hey, tuck in your shirt, boy. Aaron, tuck in your shirt. Yeah. So gradient must be going outwards. Yeah, gradient must be outwards. Oh, yeah. So you want to show that basically your dy dx is more than 0. Okay. So here you want to show that in this interval, show that your dy dx is less than 0. Is that okay? Okay. Yes. For 1.2, for proving in general, you just remember not to start with the output question, by the way. Just remember not to start with the outcome. Okay, so like for example, you want to show, I do not write this. I'll write show. Okay, every time proof itself, the outcome must be the question. So you must only prove it at the end. You cannot write assume equality from the start. Okay? Okay. So for example, I start with A, I write my f prime max. My f prime max is 3x squared plus 1. Then I'll write down since x squared is more than 0 for all x. For those of you who know set notation, maybe for the scholars, you can write this for all x's. If you understand what this means now. So it means for all. It means for all x member of R. Okay? Otherwise, you can write all. This means for all. Guys, if you want to write this, it's really cool. Right, this is my generation, the language element. This means for all. Okay, this means for all. Okay. Upside down A, yes. For all x in R. Then 3x squared plus 1 will be more than equals to 1, which is more than 0 as well. Okay, for all x real. Why? You don't have the this year's what? Sorry? The what? Don't have last year's you it's on WhatsApp. It's on WhatsApp. It's on Google Classroom also. Maybe you play with it. I think so. Because later I send to you. Okay? Just give me some. Let me finish the lesson. Can hold? Yeah. So since you show that dy dx is 0, therefore, hence, since f prime max, so this is where Tuan was talking about, is more than 0 for all x in real. Therefore, I can say that fx is an increasing function. Fx is an increasing function. Okay, so now this is x squared minus 3. I find my f prime again. I realize that for f prime, I will need the quotient rule. Okay, so differentiate left hand side, differentiate the top, get 1. Differentiate the bottom, get 2x. X squared minus 3 squared. You get x plus 3. You get minus x squared minus 3 over x squared minus 3 squared. Less than 0. Okay. So this, okay, now this is your f prime max, right? So you see, x squared minus 3 is a squared function. It's basically going to be more than 0 for all x real. But x cannot be 3, because if x is 3, you realize you will make the denominator 0. Okay? So if you look at the top, if we want decreasing function, if we want a decreasing function, it means that we want f prime x to be less than 0. This means we want minus x squared minus 3, x squared minus 3 squared to be less than 0. This means that we want x plus 3. Solve this. This is what you will get. You will get. Okay? Can I? How do I get the square root 3 bigger? How do I get from here to here? Oh, no lah. Okay, bro, you see, this one, right? Is it the same as x squared plus 3 more than, more than 0? Sorry, more. What am I saying? Yeah. I want this one less than 0. Yeah. So, if I want this to be negative, okay, is it correct? It's a decreasing function. That means I want this, right? If I want this to be more than 0, yeah, correct. But here, wait 1 second. Oh, okay. Yeah. So this is your numerator. We need for x between square root 3 and negative. Because this is what we are given, right? You can see that negative x squared. Well, x squared will just be between 3 lah. Between 3, be less than 3 and 0 lah. Correct? From this to this. Make sense? Therefore, negative x squared will be basically more than minus 3. Negative x squared. So negative x squared minus 3 will just be less than 0. Okay, because if I this, right, you see from here. Let's say I go from here to here. Can I say that let me see. X squared will be less than 3. I can also say that negative x squared also will be less than 3. Am I right? I can also say that minus x squared minus 3 will definitely be less than 0. Then I can also say that x squared minus 3 squared will be more than 0. So the top is positive, the bottom is negative. Okay, so the top is negative, the bottom is positive. Yeah, it's a bit lame, but I mean, if x squared is less than 3, negative x squared confirm less than 3. Negative x squared is less than 3. Negative x squared minus 3 confirm less than 3. So negative is at the top. Positive is at the bottom. Overall, it must be less than 3. Yeah. From here to here, you just consider this part. If x is less than 3, x squared must be less than 3. Right? I mean, okay, if x is more than, it's the same outcome. So if x is more than, if x is between, let's say for example, you think about it, negative square root 3 to square root 3. Everything here, any x that is here, it will be less than this value. If you square it, it's going to be less than this. If x is between negative square root 3 to negative square root 3, you square it, it's also going to be less than 3. Does it make sense? Example, you put 1, negative 1. X is negative 1. If you square it, x squared is 1. Is it still less than 3? It's still less than 3. Example, x is 0. 0 squared. Is it less than 3? It's still less than 3. Okay, because when we talk about the square root, it's like absolute distance between 0 and square root 3. Okay? But the good thing is also we are not solving in this case. We are just proving it based on the info you give me. Right? Okay, so I mean the thing is, bro, you already give me the interval. I just need to show it to you, man. So if x is between 3 and negative square root 3, I can easily say that for the top, no big deal. In fact, for the top, minus x squared is definitely less than 0 all the time. Minus x squared minus 3 is also definitely going to be less than 0 all the time, right? Now, in fact, the denominator x squared minus 3 square will be more than 0. Right? Except for when it is 3. Okay? Okay. Will be more than 0 for x between square root 3 to negative square root 3. So the interval here is really for the denominator. Because if I touch square root 3, right, the denominator becomes 0. If the denominator is 0, then we have a problem. So you can see here the denominator is negative, positive. The numerator is a negative. Yeah, so with a negative over positive, therefore it is less than 0. 可以吗？ Can Okay, whatever I said, I'm just going to put it here in front of you. Once you're okay, you can go to 1.3. Once you're okay, you can go to 1. Okay, I see some of you are already at 1.3. Okay, I'll get to that in 1 minute's time. Is there anyone at 1.3? Okay. Ophelia, are you okay? Yeah, okay. 1 point, you're at 2 point something. Huh? You're writing. You're reading. There's this song called The Fate of Ophelia. Is that true? Oh, do you listen to Taylor Swift? My son tell me. Okay. Okay, I see someone looking at the screen, right? So I'll pause a while. Here, it's just for your note. Just remember the basic idea is increasing is going up, gradient more than 0. Decreasing is going down, gradient less than 0. Prerequisite is you are solving inequality. Okay? Now, sin x, find the range of values in 1.3. When is it decreasing or increasing? Look at the gradient function again. Solve the gradient to be less than 0. Or basically, just look at the graph. Just look at the graph, guys. The graph alone can tell you where it will be going up and where it will be going down. Okay, where is going up and where is it going down? Put your back really. I cannot see your work. Okay. You see your back used for bisector. Okay. Huh? FX. Not F prime. F prime. Next chapter. Okay, may I move on? Yeah, okay, so now I go to 1.3. Okay, I know what you all might want to do is you all might want to differentiate, right? That is one way. You can actually differentiate and you see where well, basically, some students may do this. There are 2 ways for, now if fx is sine x, some students may do this. F prime x is cosine, right? Now increasing means what? Increasing means F prime x more than 0, right? So you want, I'm writing in very English form, cosine x more than 0. When is cosine x more than 0 in this range? Negative pi to pi. When is cosine x more than 0? Timothy, second chance. Cosine x, not sine x, cosine x. When is cosine x positive? Negative. Timothy, I show you. You will look like that, huh? So this is pi over 2. This is negative pi. Okay? Okay. This is one way. What's the second way? Simply just draw the graph. You can literally just draw the graph, right? Because the question says state. So those of you who are very comfortable, straight away you can write the answer down. Okay, you can write the answer in this way. What does this bracket mean? It means that it's a non-inclusive. Okay, I just want to start showing you all some set notation. This means x is between pi over 2 to negative pi over 2. Okay, yeah. What does the triangle mean? It's a member. X is a member of negative pi over 2 to pi over 2. These two sets are non-inclusive. Non-inclusive. Okay, huh? Okay, huh? So this just to get your, let's say for example, x is a this right? You put like that. This is member. This means x. Okay, for square means inclusive. Okay, and you go to senior high, teachers use this all the time. Do this. This one is x between a and b. It means all inclusive. Okay. This one means member. Okay, the sign is okay. And yes, ma'am. Do I have to do like that? No. No need. No need. You can write it in the blue also. Yeah. Can So if you ask me part 1, guys, if you ask me part 1, you don't have to draw the graph, but if you just observe when you see increasing, just look. Look for yourself. If you know the cosine sine graph, you will know that negative pi over 2 to pi over 2, the graph is going up. That's where the answer you can just write down into it. Oh, where is it decreasing? Here and here. Okay, just by knowing the graph. So for those of you who until now still don't know the sine graph, you will know the price is very heavy. You really need to memorize. You better do it quick. Otherwise, you'll find that you're missing on so many things. The part in green is where it's going down over here. The part where you is in pink is going up over here. Yes. Or yeah. Yeah. You mean the derivative of sine? That'll be cosine graph. That'll be cosine. That's okay as well. That's okay as well. I mean, if you are going to draw, then you might as well solve. Yeah. Then the question asks for state. So if you ask me what I would expect for you, I would hope that you only write down this answer. State. Yeah. Okay. At your level now, you should be able to memorize and draw the graph. Okay, I hope if you haven't, you know the price is heavy. Make sure you do it soon. Find a range of values for which it is increasing. So again, what do you want? You want the gradient to be positive. Okay, so far? So the gradient would be 6x squared plus 6x minus 12. Increasing, right? So increasing means you want, do you want? Increasing means you want gradient to be positive or negative? Yeah, okay, stay with me, don't entertain, okay, tell Junkai must pay attention. Okay, slow Junkai down a bit, he's too fast. Huh? Which one? 石头. Okay, where help area? Area is where? Junkai, where help area? Sit beside area. Okay. Then, okay. Julia, help me check on Joshua and Zihan. Yeah, help me check on Zihan. Fires. Okay, the rest are okay. The rest are okay. So we help me check on EV. EV means school last week. Zarisa help me check on Alanis. Xingyang. It's okay. The rest are all good. Who's missing? Ethan Yo and Edison. Okay. So now, which means that I want 6x squared plus 6x minus 12 more than 0. Divide this all by 6, x squared plus x minus 2 more than 0. Look at this, it's so beautiful, just like you. Okay, so factorizable, so mindful. Okay, so trivial. Okay. Yeah. So you see how when I change the constant term, for example, right, does it affect the values of basically? Also, what you're going to say is this, is that when I change it to another number, does it affect the range of value? It doesn't, it doesn't. Because after I differentiate, what will happen to the 10? It will disappear. 10, no more. So 10 will be gone. So basically the gradient function remains the same. If the gradient function remains the same, the increasing remains the same. Okay? And what are you doing? You are not doing something bad. Close your iPad. Is that a MacBook? Oh, you have a MacBook. Oh, you have a MacBook. There's another person who has a MacBook also, Sean. And you. And Pham Dui Hai. That's why I don't have a good impression of all people have having MacBooks. Yeah, by the way, I have one also. Huh? It's not false. It's not a false assumption. It's a good assumption. Yes. What like that? What are you doing? Oh, less than equal. Less than equal. Just say less than equal. What like that? Like that? Like that is like that. I thought you were calling me a loser. Okay. Just use less than equal is fine. Yeah. So if you want to write this, it's okay. Or if you want to write normally, x is less than -2 or x is more than 1. That is also okay. Both are okay. Both are okay. Okay. The red one, okay. The red one, if you want to write x between pi over 2 to negative pi over 2, that's also okay. Why got not equal? Because when it's equal, the gradient is 0. It's not less than 0. Our requirement, our criteria is must be more than 0. So when it's 0, we don't count. That's why you see some percentage. Here to here is more than 0. Here to here less than 0. Here is 0. Remember the tangent is a horizontal line. Why is the square bracket here? Because at this point, the is going down. And the pi, you can indeed check that it's still negative. Okay? But that is a very, very good observation. Very sharp. Okay, I don't think anyone in this class saw it. Okay, wait, you don't rush. Just do slowly. Do your practice set 1. Do topic 6 practice set 1. I asked you to help Ariel, you got help. Ariel, I see help you. Hasn't. You never help. Help her. She can do more pull-ups than you. Okay. Okay, than me also than you. Yes. Okay, so I go on. I have you copied this thinking time. I am very sure Isaac has copied. Okay, copy the thinking time. I'm very sure Isaac has copied. Okay, I'm very sure Chloe is copying now. Shut up. One. Don, why are you so distracted? You just buy a MacBook Pro. Okay. Which one? Huh? What do you say? The one that I bought was about $1,000. So I got it at sale, Shopee sale. Huh? So far it works. Actually, I don't know. But I don't need very expensive. Give me fake. If I can use it for long, then it's still okay. Yeah. Must be thrifty. Oh, I don't know, but it works. It works well. You can download App Store. Cannot be too expensive. Luxury, once you enjoy, becomes a necessity. Simplicity, once appreciated, becomes a sanctuary. Huh? That's very what? The law. Huh? Which one? No money lah. Huh? Oh. My one I use for 7 years. Maybe you can change. See how. I still owe you a Starbucks card. Okay, can I go on? Okay, so now I guess this Thursday's AFL is going to be face the front. Joshua, 懂事一点. A lot of teachers are coming to talk to me about you. It's not a nice thing. Yeah. So, what cute one? I said you like 一只啊? Why you see her say cute? Then you say 一只 was cute. Huh? 4/3 pi r cube. 4/3 pi r cube. Okay, when it's a volume, the variable is always a power 3 usually. When it's an area, it's power 2. Okay? So, may I go on? So now, I talk about connected rate of change. Okay, just a heads up. This chapter, likelihood, is going to be inside your Thursday's AFL. So, E&I. Okay, but I'm going to start teaching because it can be a little confusing. Okay, so I need you to pay attention. Actually, very easy one. Now, what is the rate of change and how do we find a rate of change? I hope you all still listen to me now. Don't do your question. I know you're very eager, but hear me out. Let me teach it to you from my point of view. Okay? So what is the rate of change? How do I find the different rate of change? So now there are going to be different letters in your derivative. Okay, now you can see that there's dy dx. What does dy dx stand for? It stands for the rate of change. Okay, so remember what does this d stand for? The differentiate or the change, right? The change of y with respect to x. Okay, then what about dv dt? The change of velocity of volume with respect to time. So now if you look at the real life situation, right? You look at real life situation, the fact is there are so many if not you. So if you see there's y, there's x. So any graph there will be y dx, right now. But let's say today you pour water, you take a cup of water, you pour. If you pour, the volume changes with respect to time as well. Correct? So you can have also a dv, sorry, the volume versus time. Then the graph, the derivative will be dv dt. If I have a volume, or let's say a radius versus time, I pour the water on the floor, the water spreads. Then what kind of radius will I have? Yeah, right? if I have a volume versus the radius. Right? Now I look at the volume. It should be going up. If the radius increase, the volume should increase, right? See, I have some graphs. Then what kind of gradient? What kind of gradient are we looking at? Yeah, okay. So now the three derivatives, right? Actually, they are related. That's why they call it a connected rate of change. Okay, connected rate of change. Okay, so far. Okay, so far. So that's all there is to this chapter. Actually, it's very chill one. Now, what I will be telling you is now, now, how are they related? The relation is like who's this? Yours. I just find it as so how are they related? Okay, now you see okay. dV/dt, right? Is one derivative. Okay, now think of it. Okay, think of it like a fraction. It's like a fraction. It's something like dV dt dV dr times dr. Can you see that in the same cancels out? This is called the connected rate of change equation. Connected rate of change. Connected rate of change. A connected rate of change equation. It's a fraction. Can you see? So how you form it? You can see that these two are dV dt. I purposely use black color so that you all can see. All three derivatives are connected this way. Okay. So in the question, what will you see? Okay. Usually this question, a math question that's connected rate of change, what derivative they will give you? One derivative is your answer. One derivative you have to find. Okay. So what's the prerequisite now? As those of you, Sitong, Junkai, Mitra, you might have been doing topic 2 questions, these questions by now. Then you realize, what do I need? I need to know distance time. I need to know mensuration formula. Volume. Mensuration. Okay, mensuration, I mean volume, surface area. The formulas. Okay, okay, so that means, okay, if I talk about dV/dt, this one is the rate of change of water with respect to time. Y equals 1 over T. T can basically sub. So if dV/dt is negative 1 over T squared, let's say this is the formula. And T equals to 2, you sub in dV/dt is negative 1 over 4. It means the rate of change is negative 1 over 4. That means the gradient is negative or positive? Is the gradient negative or positive, Jaden Lloyd? Not very obvious, but I'm just basically pointing at the answer. Negative, right? So if your gradient is negative, is the volume of water going down or going up? Not very obvious, but I'm showing you my answer. Yes.
So we have to memorize like the volume.
Yes, to memorize. Can I memorize? Yeah, memorize or sacrifice. Okay, which one you choose? Okay. You want to go and run? You go and run now. 2.4. You want 2.4, is it? Mr. Sir, which one wants to run 2.4? Quiet. Shut up. Look at the front. Javier, look at the front. One more time, you all ask each other about other question. I'll go through it. Wait. Okay. So I go through 2.1. 2.1. Is it okay? Okay, you all start now. Give it a try. So, area finish already? 1.3. Can anyone haven't do 1.3? Junkai, have you done 1.3? No, Junkai, why am I looking at you? Joshua, have you done 1.3? Okay, go and do that. Okay, so now I will go to 2.4. Okay, can for the 2.4. Okay, I just give you a hint. Simple. Now, in Mitra, in part 1, have you found the RDT? You haven't do part 4 yet? Or no? Okay, so the RDT, okay, from the formula, okay, the three derivatives are, this is what? dV/dt. Can you see? This is dV/dt. Volume changes with respect to time. Right? Now, there are three derivatives, right? One will be given. This is the one that's given. One is your reward. That is the one that you reward. What's the reward? Your reward is to get the RDT. Which is the third derivative? One is the given, one is a given, one is your reward. Who's the one that's hidden? Very good, right? DVDR. Every variable must appear 2 times DVDR. So now Mitra thinks that she needs DVDR. Then Mitra will ask herself, okay, if I need DVDR, I will need to differentiate B with respect to R, correct? So I will need B in terms of R. Right? Can I? Can I? So then I know what is V. What V are we talking about? We are talking about a sphere. What's the volume of a sphere? What do you call a sphere that keep moving around? Shakespeare. Okay, anyway. So this is differentiate 4 over 3 pi r cube. Okay? Can? Can can you keep quiet? You are talking to Dorcas all the time. Okay. Talk to Dorcas, talk to Timothy, talk to Xavier. Okay. So now I go through to 2.1. Now the thick cardboard is placed directly under a leaking tap. The drops form a circular stain. So you can see the water drop, and form a circular stain. Okay? When R represents the radius, such that R is equals to T squared. Find the rate of change of radius. What derivative do you think they want us to find? Can anyone tell me what derivative they want us to find? The R dt, okay? The R dt. Rate of change means the R dt. So here, the R dt, what is it? It's just 2t. Wei Xiang, Ethan, what are you doing? Okay. Looks like you all already prepared a live record. Okay, so at t equals to 6, the R dt should be equal to, which is 12. So the answer is 12 cm per second. Okay, ma? You want? Don't joke anymore, huh? No, you differentiate 4 over 3 pi r cube. So the what you get is 4 pi r squared. So the fun fact is this. You know, Mitra, when you differentiate the volume of sphere, you actually get the surface area. Right? But 4 over 3 pi is just a constant. R is the one that you differentiate. No, you differentiate, then you start in 10. You differentiate first. The 10 is not something, it's a constant. So that's already differentiated. You understand? Yes, 10 start there. But you have to find what value to start with. Can find one. Yeah. Okay, so now I go to 2.2. So guys, you see, what's the unit for dr dt? Radius is cm. Time is seconds or minutes. Okay? Can? Now, when we found the rate of change in 6 seconds to be 12 cm per second, you can make use of the chain rule to connect variables to each other. So the fact is, in life, there are so many derivatives that are connected. Okay, there are so many derivatives. So, yeah. So just like pouring a water in, you can see that the variables that we're looking at when we pour water can be height, can be volume, can be radius, can be time. So many things, right? Yeah, those who do physics, you will love it. So how to know the connection? Remember, there are always 3. One is given. One is the one that you want, the one that's the reward. One is hidden. It's like the younger brother hiding under the bed. Okay? One will always be hidden. Okay, then you form the rate of change. Remember, do it like a fraction like that. Can? Can connector rate of change, A level also tested. Make sure you know. Okay? Yes, Megan? Oh, yes, yes, Sue. Question 2.2. What is DSDT? DSDT is let's say you call S as surface area. It's a change of surface area with respect to time. It's the same as dsdr times dr dt. Okay? So you can see it cancels off. Okay, okay. Just take note that usually time is the denominator. Okay? Yeah, usually we find dv dr, not dr dv. Okay, because we have volume in terms of radius, not radius in Joshua, what did I just say? In terms of what's wrong with you these few days? Can you pay attention or not? Huh? Can? Yeah. I thought you're a good kid, you have some conscience. 为了你的老师努力一点，可以吗？可以来。dv this is the same as dv dt times dt dr, correct? So we can write it this way, but we know that usually we do not differentiate time with respect to radius. Usually we differentiate radius with respect to time. So how do I write this? I can say that this is the same as this. Guys, look, look at this magical moment. I change this. Can I say this is the same as this? Can I say that this is the same as this? Now look carefully, this is the same as this. Or so there is dv/dr. Okay. What about dsdt? I can form I can write it this way, right? I write the variable to be cancelled out. I write my one-third guy at the numerator, one-third guy at the denominator. This two I cancel out. Then I ask myself, does this make sense? Do we do dx/dA? Usually we don't. We do dA/dx. Okay? Do dA/dx. Okay? Can A with respect to x. These are differentiate A over x. Oh? Zihan, can you please stay away? Okay, can Hello, what? It's again? Okay. Usually, time is usually the denominator. Okay, the choice per unit. Because usually time is the x-axis. Radius compared to volume, usually radius is the denominator. Because most people write volume this way, right? You all usually write this formula, or do you prefer to differentiate this formula, or do you prefer to differentiate this formula? Which one you want? This one, right? This one you can do dv/dr. This one you do dr dv. Good luck to you. Okay, that's why usually volume, if we talk about radius and time, usually time is the denominator. If you talk about volume and radius or height, usually radius or height is the denominator. 可以吗？可以的。 So what are they telling you, right? Here, which derivative are they giving you? This is the one that is given. What is the reward? The reward is dy dt. What is needed? Who is hidden? Dy dx. Okay. So you find out dy dx. Then you sub x to be 1. Okay. Then you find your answer. So you should get, if I'm not wrong, cannot. You should get, I think, negative 10 over 3. No. I'm not sure what is it. I think it's negative 24 plus negative 20. Correct? You got 4. What's your dy dx, bro? So your dy dx should be negative 24 over x squared plus 48x. Correct? So, hey, oh yeah, you're right. Wait. Yeah, the teacher made a mistake, sorry. Yeah, 4 is correct. 4 is correct. So 48 times 1, right? Shouldn't it be 24? So this is negative. So dy dt, right, will be dy over dx times dx over dt. So the answer is 24 times 1 over 6, which is 4. 4 unit per second. You see? Okay. Go toilet and wash your face. I'm going to end class already. Okay, yeah? Same. It's the same. And x equals to 1 and x equals to 1, it doesn't. This is for you to sub in here as well. So that the x equals to 1 applies to all situations. Then my derivative. No derivative can change. Oh. Okay. Yeah. Different again. Volume is a formula, right? But with the volume formula, you can find volume, for example, with respect to R, dV dr. You can find dV dt. So let's say, Mitra, for example, volume is 4 over 3 pi r cubed. When I differentiate this, 4 pi r squared. This means that when R, for every 1 unit of R that gets bigger, the rate of change of volume is 4 pi r squared. This makes sense, right? Getting bigger. But volume is a formula, it's not a derivative. That's it. dV dr, there is a derivative.
Why am I differentiating the volume component?
Okay. You're doing for part 1 or part 2? You're still at part 1. Now, part 1, you find the dV dr, right? So that is 4 pi r squared, right? Because you differentiate with respect to R. Okay? R cubed goes in front is 3r squared. Understand? Another is 3r squared. It's 3r squared. So 3 goes in front is 3. This one is r squared. 4 over 3 pi r cubed, right? The r cubed becomes 3r squared. And the rest of you keep quiet. R squared. Clear so far? So this is 4 pi r squared. Okay? Thanks. I got no voice already. Yeah. Clear so far? So this is dV dr. This is dV dr. Now, the rate of change equation, right? You must know 3 things. dr dt. Yeah, you get it, So dr dt, what do you need? Okay, so dv dt is dv dr times dr dt, right? Correct? That's why it's this divided by this. That's why you need dv dr. Okay? Okay, I will stop here. Tomorrow we continue on practice set 1. Okay? Okay, thank you, class.